Number 2, here we are continuing with our solving with trig, and today we're going to open it up and go on the open interval as opposed to the closed interval 0 to 360. But that is where we start. A problem from the previous 2 lessons here, solving on a closed interval 0 to 360. Okay, 2 times cosine minus 1 equals 0. We're trying to get cosine by itself, so we're going to add the 1. And divide by 2. So where is cosine equal to 1/2? If we're talking unit circle, remember cosine is your x, so we're barely over and barely over. So that would be 60 degrees and 300 degrees. Now, that was how we had done it the last couple days. Now we're going to open it up to the open interval, meaning we can keep spinning around and around and around, forwards and backwards. So if I went another loop around the circle, 60 degrees, and I go all the way around and back, now I am at 420 degrees if we add another 360. And I can add another 360 and be at 780. And we can keep doing that. I can go backwards around the circle. And instead of being at 60, if I go backwards, minus 360, we'll be at negative 300. Okay? And we could do that for this one as well. So, how can I account for that? How do I write this answer without having to sit here and write out an infinite number of answers? Okay, we're going to start just like yesterday. We're going to say 60 degrees. And then these are all full circles, right? These are all full circles. These are all 360s. So plus 360 times n. And just for today, we're going to make a note over here to the side that n is an integer. That'll probably take you back to the pre-algebra days when you had to classify number sets. Remember, integers are positive and negative whole numbers, like negative 3, negative 2, negative 1, 0, 1, 2, 3. So that should account for all of our positive and negative spins. And we'll do the same thing for 300 degrees. Plus 360n. Alright, so that's all we're really adding today is plus 360n, or, as you'll see in the next one, maybe instead of 360, it's just going to be plus 180n. Let's take a look. Let's get sine by itself, so we're going to add the 1. And divide by 4. So sine squared equals 1/4. We're going to square root. Remember when we square root a fraction, we do the same thing as the square root of the top, the square root of the bottom. Okay, square root of 1, we're going to have plus minus 1 over 2. So we're thinking about where does sine equal plus or minus 1/2 at? Okay, sine is up and down, so we're barely up and down. So that would be 30 degrees, 150, 210, and 330. That's where sine would be plus or minus 1/2. Okay, so we could go 30 plus 360n, 150 plus 360n, 210 plus 360n, 330 plus 360n. Not a lot of fun to keep writing all that out over and over and over. Okay? Do you notice anything, any patterns here? 30 and 210, that's 180 degrees, that's half a circle. They're straight across from each other. So I could combine those two and do 30 plus 180, and that'll hit that one, and back to that one, and that one, and back to that one, and that one, and back to that one. So we could put those two together, and instead of having a plus 360, we could say 30 plus 180n, and that'll end up take care of both of them. And we could do the same thing with the 150s and 330. They're straight across from each other, so I could just do 150 plus 180n, and that'll end up taking care of both of them. Okay? Let's see, go ahead and push pause and try the next one. I know it's our first one with the radians, and that one is a little bit tougher because you have to think about fractions. Okay, let's see if you can push pause and give that one a go. Alright, let's see how we did. Cover it up a little bit here. Okay, so they both have a cosine, so let's factor a cosine out in front. And then where does each one equal 0? Well, this would equal 0 and cosine is 0. 2 sine plus 1 equals 0. Subtract the 1, divide by 2, or that'll equal 0, and sine is negative a half. Where does that happen at? So we have those two, which are straight across from each other, and then these two. So with these two being straight across from each other, you're thinking like plus 180, but we're in radians, so to think pi. So 180 degrees is the same as 1 pi. So we would have pi over 2 plus pi n. And then with these two, there's no partners, we're not straight across. Okay? So it's just going to be those two plus 2 pi n. So that's 3 pieces. However, this would have been tough to see. I wouldn't necessarily expect you to be able to do this one this way, especially right off the bat. If you put these all together on the same one, you have these two and these two. Okay, you could get down to using just 2 lines for your answer by doing it this way. This is going to be tough to see. Okay, right here, 7 pi over 6 to 11 pi over 6 is a gap of 4 pi over 6, which is 2 pi over 3. And this is where knowing all your fractions is going to help. Okay, how big of a gap is this? This is pi over 2 to 7 pi over 6. So if we did common denominator, pi over 2 would be 3 pi over 6, which means this is another gap of 4 pi over 6 or 2 pi over 3. Same thing on the other side. So if you get like the little like peace sign looking thing, it's going to be 2 pi over 3 or 120 degrees between. So we could do pi over 2 plus 2 pi over 3n, but then we would just have this guy left over by himself to do plus 2 pi n. Okay? So I wouldn't necessarily expect you to like break apart a pair that are straight across from each other in order to make like a triangle one, a 3-piece one. If that were to happen on a quiz or a test, it would probably just be the 3 pieces and not necessarily the 4th one. Then, if it just had those 3 pieces, then I kind of would expect you to get that. Okay? The other possibilities that we can look for, if things are straight across from each other, it's going to be 180 degrees or pi. If you get the radical 2s, the plus minus radical 2 over 2, those are all going to be 90 degrees apart, or pi over 2. And this one's the trickiest one, because it makes like a y, and they're going to be 120 degrees apart, or 2 pi over n. But this y can rotate. Okay? It might make a sideways y. It might be upside down. Okay? It's tough. That was the toughest one to see. Alright? So that's the kind of stuff we're doing. It's nothing really different than before. We're just adding on the plus 2 pi n's, plus pi n, plus 180, plus 360 type of stuff. Okay? Thanks for watching. Good luck on your homework. Let me know if you have any questions.